Hey guys, welcome to episode 4 of my Vulkan tutorial series. As always, make sure you've seen the previous episodes and get your coffee ready. I hope the coffee gods can forgive me, just this once. So, now that we have our triangle, there's a lot more we need to do as that was only the beginning. So let's create our next to-do list. As you can see at the end there, I'm going to make the GitHub repository public at the end of this series. That's mostly because I want to show employers my source code. I need a job, please help me. Currently, we're waiting for our previous frame to finish before we can start rendering the next. We can fix this by allowing multiple frames to be in flight at once. Each frame should have its own command buffer, semaphores and fence, so we've changed these application attributes to vectors. We also have an unsigned integer to record the current frame. We will loop through these vectors to destroy the objects in the cleanup. Also, we'll resize our arrays and loop through them when creating the relevant objects. Finally, in our drawFrame function, we need to use the attributes for the corresponding frame, so we'll replace the old variables with the vectors at the index of the current frame. And then don't forget to update the current frame at the end. This should be everything, and you can see that we aren't getting the warnings we received last time. Now, at the start of this series, when we set up our glfw context, we set resizable to false. This is because until now we have had one swap chain which is only compatible with the original window size. In this step, we are going to set up a function to recreate the swap chain when it's no longer compatible with the window surface. For example, if the window is resized. We have a resize callback function which will set a resize boolean to true, indicating that the window has been resized. We'll abstract the swap chain cleanup into a function because we'll need to call it every time we recreate it. Create a recreate swap chain function as well as a cleanup swap chain function. And then when we acquire the next image, we will need to check if it's out of date, in which case we will call the recreate swap chain function. Also, when we queue, we need to check if the frame buffer has been resized or if it's out of date again, in which case, again, we'll call the recreate swap chain function. If we run it now, we can't resize the window because I forgot to set glfw resizable to true, so let's just do that quickly. And now if we run it, we can resize the window with no problems. This next step we'll be using GLM, so include it at the top. Next up, we're going to replace the hard-coded vertex data in the vert shader with a vertex buffer in memory. We've checked previously that GLM has been included in the project, so we can store position and color in a vec2 and vec3 respectively. We need binding descriptions to tell Vulkan how to pass this data format to the vert shader once it's been uploaded into GPU memory. In our attribute descriptions, we use R32G32SFloat for position because it's a vec2, and R32G32B32SFloat for color because it's a vec3. I'll store the same vertex data for our triangle in a vector. I realise now that I have actually changed one of the positions. And in the cleanup, destroy the buffer and free device memory. In our application attributes, we need a VK buffer and VK device memory. our record command buffer needs updating too. Create a function to find the memory type of the physical device, which we'll need to create the vertex buffer. Update the vertex input info in our pipeline. Now create the vertex buffer and allocate the memory. Next, we need to update our shaders to accommodate these changes. So remove the hard-coded vertex data and add our two inputs of position and color. Make sure the locations match those of the attribute descriptions. Then use position in GL position and color for V color. Make sure the variable names match the frag shader so that it takes an vec3 called vcolor before compiling with our bat file. Remember that if we don't compile to spare V, it will still be using the old shaders. And then running it, we should have the same result. The triangle does look different because, as I mentioned before, I changed one of the position values. Finally, for this video, we are going to use intermediate functions to create our buffers using staging buffers. The first one will be a create buffer function that takes in parameters for size, usage, properties, and the references for buffer and buffer memory. We'll create another function for copy buffer, which will take in parameters of source and destination buffers, as well as the size. Using these new functions, we can refactor our create vertex buffer function to use them with a staging buffer. That way we can transfer data into device visible, host non-visible memory, whereas shared host device buffer access without staging needs memory to be both device and host visible. That was quite a mouthful, but that's the end of today's video. As always, join the Discord to talk about game development. You can follow me on Instagram, X, Patreon, Coffee, and all my links are on my website. Leave a like if you enjoyed, a dislike if you didn't, a comment on what you want to see in the future. Thank you all for watching, I appreciate it, and I hope to see you in the next one. Bye!